Here's a little bit of homework help for Unit 5, Lesson 20. Volume of a sphere. Keep in mind that the volume of a sphere is equal to 4/3 the value of the ratio of pi times the radius to the third power. This first question, we're supposed to match each description right here with one of these values down below. I'll help you out with part A. We're going to find the volume of sphere A. The volume is equal to 4/3 pi times the radius, 4, raised to the third power. As we simplify, I'm going to rearrange just slightly using commutative properties so that I get pi on the outside. This is going to be 64. I like to have my fractions when I'm multiplying fractions, a fraction times a fraction. You may not have that same piece that you want to do with that. That's okay, it's up to you. By the time I simplify this, 4 times 64 is 256. 3 times 1 is 3 times pi. Now I may consider going ahead and dividing that, but what I noticed is number 2 has that exact same value right there. So I know number 2 is sphere A. Give that some work on the next 3 of them. Match up 1, 3, and 4 with the correct values up here, knowing that sphere A goes with item 2. Skip over that next question and come to one that talks more about a comparison of two different spheres. Again, remember that we have sphere A with a radius of 2 centimeters and sphere B with a radius of 4 centimeters. Calculating the volume of a sphere, again, volume of a sphere is equal to 4/3 times pi times the radius cubed. So when we look at this and we want to find the total volume of sphere A, I can take the volume of sphere A is equal to 4/3 times pi times the radius that's given of 2 to the third power. When I go to solve that one, again, I like to go ahead and rearrange by the commutative property to get these values. We'll put 8 here, number 1, to be multiplied by pi. And then I find out that that volume that's being given right there is going to be a volume of 32/3 times pi. So once we find that volume, I can go ahead and plug it in right here for the correct answer, and then I calculate the volume of sphere B using the same thing, only substituting with a different radius. And then in part C, we're seeing that it says the radius of sphere B is doubled that of sphere A. We saw that because the radius was 2 and 4. How many times greater is the volume of sphere B? Give that a little shot right there to figure out how many times greater. Be really careful about what you're seeing. Just because the radius is doubled doesn't always mean that the volume is going to be doubled in a sphere. We have a little bit different rules for that one. This next part right here, you have 3 cones, each of which have a total volume of 192 times pi cubic centimeters. You have cone A that has a radius of 2, cone B that has a radius of 3, and cone C that has a radius of 4. Okay, keep in mind they all have the exact same volume. So what does that mean? Well, that means that the height is also changing because the radius is also changing. So when we go to find these, like when we find cone A, remember the volume for a cone is equal to 1/3 the volume of a cylinder. So pi times the radius squared as the base times the height. And I can substitute the known values that I have. 192 times pi is equal to 1/3 pi times the radius of 2 raised to the second power times h. My goal is to get h by itself. So what I want to do with this is take 192 times pi is equal to 1/3 times 4 over 1 times pi times the height. The reason I do this is because it's just a little simpler for me when I put the numbers next to each other. I continue and I find that that's 4/3 of pi. So I'm going to go ahead and erase this and just write 4/3 of pi. And now to get the height by itself, simply divide by 4/3 times pi, and divide by 4/3 times pi. And I think that this is the part where it's really helpful to remember pi divided by pi is 1. So that means that all I have to do is do 192 divided by 4/3, which is the same thing as 192 times the multiplicative inverse or the reciprocal of 3/4. Pull out that wonderful calculator. 192 times the numerator of 3 is 576. And then we'll go ahead and divide that by 4, which equals 144 for H. There's the height for cone A. I'm going to leave it to you to find the other heights for cone B and cone C. This next one represents a graph going back to functions and reading functions. It says the graph represents the average price of regular gasoline in the United States in dollars as a function of the number of months after January 2014. How many months after January 2014 was the price of gas greatest? So after how many months? So we want to look at these and see after how many months was it the greatest. That should be a pretty simple call just by looking at the number of months and find the highest peak of this graph. Question B, did the average price of gas ever get below $2? Well, we're going to read over here on the y-axis now and think about where we're at with $2. Did the average price ever get there? Yes or no? Describe what happened to the average price of gas in 2014. You're going to go ahead and look at this whole graph and say, on average, what is the average price of gas doing in 2014? Make sure that whatever you do in here, you're giving me information or giving me evidence that supports the claim that you're doing. If you just say the average price of gas went down, I will not accept that. You're going to have to give better evidence that supports the structure of the constant rate. With that going, yes, we can tell that the average price of gasoline decreased over that amount of time. However, that's not the only thing that happened. You need to tell me about those different pieces that came into play there, like that piecewise function. I believe that's the last question for your homework. So give it a roll and make sure you have a great day. Thanks for checking in. Don't forget to check in with me if you need more help on any of these problems. Take care.